When we combine small droplets, let n droplets, there are n droplets. Before combination, drops in form of droplets, small droplets. And radius of each drop is let small r. Each drop is a charged drop having some value of charge. So before combination, radius of each droplet is let r and charge on each droplet is let q. The capacitance of each droplet is let c. The potential of each droplet is let v, and potential energy of each droplet is let u, and surface charge density is sigma. These are the parameters of each droplet. Now when they combine together after combination, forms a big drop, let its radius is r, charged. The parameters changes after combination. Its new radius is let r and the total charge is let q. The new capacitance of big drop is let c dash, and new potential of bigger drop is v dash, and new potential energy is let u dash, and new charge density is sigma dash. Now we will discuss in which way these parameters will change one by one. First we will check how the charge changes, because the charge before combination on each drop is q and total number of droplets is n. Charge on each is q. So total charge of all n droplets will be nq. All n droplets when combined together form a bigger drop. Let the total charge is q according to conservation of charges. The total charge on big drop is sum of all charges on small droplets, that is nq. Next we will discuss in which way the radius changes. Radius of each small drop before combination is r and there are n droplets. When combined together makes a bigger drop, charged bigger drop. Its radius, new radius is r, because we know as per conservation of mass, total mass before combination will be same as total mass after combination. We also know that density is mass upon volume and mass is density into volume, because the material is not going to change. If the droplet is of water, again it will remain water. So the mass and density are same. In this way the volumes will also be same. So we can conclude that total volume before combination equal to total volume after combination. Total volume before combination is n into volume of one drop, that is 4 upon 3 pi r cube, and total volume after combination of bigger drop is 4 upon 3 pi r cube. From here we can calculate r cube is n r cube and r is n to the power 1 by 3 r. So new radius is n to the power 1 by 3 into r, or you can say that new radius is cube root of n into r. Next we will discuss in which way the potential changes, because each drop having radius r and charge q have potential. Potential on each droplet is, let V as per definition, this will be 1 upon 4 pi epsilon 0 q by r, because bigger drop have total charge q and radius r. The potential of bigger drop after combination, let V dash, will be 1 upon 4 pi epsilon 0 q by r. We know that total n droplets are there, and we have already relations of radius n to the power 1 by 3 and total charge is nq. So potential on bigger drop on placing these nq n to the power 1 by 3 r, from here 1 upon 4 pi epsilon 0 n to the power 1 minus 1 by 3 into q by r, that is n to the power 2 by 3. So V dash is n to the power 2 by 3 into 1 upon 4 pi epsilon 0 q by r is potential of small droplets. In this way we can conclude that the potential of bigger drop is n to the power 2 by 3 into potential of a small drop. Next we will discuss in which way the capacitance changes, because each drop have radius, and let the capacity of each drop is C. Bigger drop have radius r and its capacity is C dash. Capacitance of each small droplet C can be given by 4 pi epsilon 0 r as per definition of a spherical conductor, and capacitance after combination will be 4 pi epsilon 0 r radius, where we have already established the relation n to the power 1 by 3 r. If we put here 4 pi epsilon 0 n to the power 1 by 3 r, we can write n to the power 1 by 3 into 4 pi epsilon 0 r. In this way n to the power 1 by 3 the old capacitance. It means that the new capacitance is n to the power 1 by 3 capacitance, old capacitance of each small droplet. Now we will discuss about potential energy. Let each droplet have potential V and capacitance C. As we have discussed earlier, there are n droplets After combination, its potential becomes V dash, its capacitance is C dash. Then we know that potential energy of each small droplet can be written as 1 by 2 CV square, where capacitance and potential energy of bigger drop after combination is if U dash can be written as C dash V dash square, where we know that C dash is n to the power 1 by 3 C and V dash is n to the power 2 by 3 into V. As we have discussed earlier, C dash is n to the power 1 by 3 C and V dash is n to the power 2 by 3 V. We can use this relation here, and the new potential energy, if we substitute these values, n to the power 1 by 3 C and square of V dash square, so this will become n to the power 2 by 3 4 by 3 and V square. It means that U dash is equal to n to the power 1 by 3 and n to the power 4 by 3 max n to the power 5 by 3 into 1 by 2 CV square, that is energy of each droplet. It means that we can conclude that energy of bigger drop is n to the power 5 by 3 energy of each small droplet. Lastly, we will discuss about charge density. Every charged droplet having charge sigma before combination, there are n droplets. After combination, the bigger charged droplet have a charge density sigma dash. We know that as per definition, charge density of each small droplet sigma is Q by A, or can be written as Q by 4 pi r square, where A is area 4 pi r square, and charge density of bigger drop sigma dash can be written as Q dash upon A dash, or total charge Q upon A dash, whereas we know that total charge Q is n times charge on each drop and old radius is n to the power 1 by 3 radius of each small droplet, as we have studied earlier. Total charge is nq and radius is n to the power 1 by 3 radius of a small droplet. If we put these two, and we can write Q by 4 pi radius of big drop, so the new charge density nq 4 pi n to the power 1 by 3, this becomes n to the power 2 by 3 r square. Here n to the power 1 minus 2 by 3 will become n to the power 1 by 3 into Q upon 4 pi r square is charge density of each small drop. In this way we can conclude that the new charge density of bigger drop is n to the power 1 by 3 the charge density of each small droplet. Let us revise again. When we combine n droplets, the new radius is n to the power 1 by 3 or new charge will be nq, new capacitance will be n to the power 1 by 3 old capacitance of each droplet, new potential will be n to the power 2 by 3 old potential of each droplet, New energy will be n to the power 5 by 3 old energy. New charge density is n to the power 1 by 3 old charge density.